For this problem, it's going to be in section 16.3, which has to do with the Fourier series. We're specifically going to be looking at the effect of symmetry on Fourier series. To the left, we have a equation, or not an equation, but we have a waveform that is of even symmetry. So it looks something like this. We have a whole page on 145 dedicated to it, and this is the functions that we're going to use for it. So for this question, it's first asking us if we need to, or what is our average value. Now, we're not going to necessarily do all of this. Our AV is actually given to us if we look really closely right here. So AV is 0 volts, but we could find it by doing the first function for our even function. Now we need to write the expressions here. Well, the expressions are going to be super simple. I've included this right here. This can be found also in the notes linked below the like button. It's somewhere not, possibly not in this section, but somewhere around this section, and it's good to memorize. We have our average voltage out front, and then we have our AN, we have our cosine n omega naught t minus our theta n. And we are going to use this to plug in for B and C. We need to answer the next two questions that are in the order of magnitude, identify the cosine or sine in the frequency of our sinusoidal rods per second. Well, typically we're going to want to solve this in cosine, so these are both going to be cosine. For the first one, we want to plug in when n is equal to 1, so let's plug this in. We know that for our v1 of t and for our v5 of t, both of these, the average value out front is going to be 0, so we're not concerned about this. So we just have our going to infinity, n is equal to 1 summation. We are starting at n though, so we don't need the summation. We are just saying that n is equal to 1 for the first one. And we're going to plug in our values. So our a of n we know as this right here. So we are going to have a negative 8 times our Vp, which is given to us as 50 volts. This is going to be divided by our n, which is 1, times our pi, and this is both squared per the formula. And then we are going to have the cosine. Inside of here we have our n, which is going to be 1, our omega, which we know is 2 pi over t. T is the period, and we are given the period right here, 5 milliseconds. So we can just replace this with 5 times 10 to the negative cubed, because that's what a milli is, times t, and then we're not going to have any angle, so our angle is just going to be minus the theta n. Now our b of n is 0 volts, and that's good because otherwise we would do like a plus b of n cosine and dot dot dot. But since this is 0, we don't need to worry about that. And if we plug this part into a calculator, we are going to get approximately negative 40.5. And that's the answer to the first part. We're going to have negative 40.5 out here, and then we have something in front of our t. Well, since this angle, we don't have anything, it's going to be 0. All we need to plug into our calculator is 1 times 2 pi divided by parenthesis 5 times negative, or 10 to the negative 3. And then inside of here, we are going to get approximately 1,256 times our t volts. Now we're going to do the same exact thing when n is equal to 5, right? Because we're just looking at summation. We're just going to be replacing this with 5, and we are going to be replacing this n right here with 5, since this is an n as well. And then if we do that, for our answer, we're going to get approximately negative 1.6 and also 6,285 t. And that's how we would look at this problem, as well as the notes that would go along to help study for something like this on an exam.